Today, we're going to pull back the curtain and reveal a fascinating secret: how artificial intelligence actually reads and understands your words.
Have you ever typed a question into an AI and just been blown away by its response? It feels like magic, doesn't it? As if it's really, well, thinking. But how does it get from your words on a screen to a coherent, meaningful answer? Well, it's not magic, but it is absolutely brilliant. And today, I'm going to walk you through the simple three-step process that every major AI uses to turn your words into a language it understands, the language of numbers. And by the end, you'll get it, I promise. All right, so before an AI can even begin to understand what you've written, it has to do what any good chef does with their ingredients. It has to break them down into smaller pieces. So let's dive right into step one. This first step is called tokenization. And seriously, think of it just like a chef prepping a meal. You know, they don't throw a whole carrot into the stew, right? They chop it up into smaller, manageable bits. Tokenization does the exact same thing, but for your sentences.
Let's take a super simple example. If you give the AI the sentence, "AI is great," the first thing it does is chop it up into individual pieces or tokens. So in this case, it becomes AI is and great. Each of these is now a token that the AI can actually start working with.
Now here's a cool detail. There are a few different ways to chop up text. The most advanced models, like the ones that power GPT and BERT, use a really clever method called subword tokenization. This allows them to handle new or weird words by just breaking them down into familiar parts. It's a huge reason they're so flexible and efficient.
Okay, so the AI has its tokens, its little chopped up ingredients, but they're still just, words. How in the world does it learn what they actually mean? This is where the real magic starts to happen. It's a process called word embeddings. I want you to imagine a gigantic, multi-dimensional map. The AI takes every single token, every word, and gives it a specific location on this map. And the main rule is simple. Words with similar meanings are placed close together, like neighboring towns. So for example, on this huge map, the word king would be located right next to queen because, well, they're related in meaning. But a word like banana, that would be way off on a completely different continent, miles and miles away from king.
And this is the secret sauce. It's how the AI develops an intuition for language. By learning that strong and powerful should live in the same neighborhood on its map, it starts to understand context. It can even figure out complex relationships, like Paris is to France is the same as Tokyo is to Japan. It's all about relationships, all captured in pure math. It's amazing.
All right, we are almost there. The AI has its tokens and it understands what those tokens mean. But there's one absolutely massive problem left to solve: order.
See, modern AI models, the ones we call transformers, have a really unique way of working. They look at all the words in your sentence at the exact same time. This is what makes them so fast, but it also means they have no natural clue which word came first, second, or last. So, how do they get grammar?
Just think about this for a second. The sentence Alice loves Bob and Bob loves Alice, they use the exact same words, the same tokens with the same meanings. But the order changes everything, doesn't it? The meaning is completely different. Without knowing the sequence, the AI would be totally lost.
The solution is this really elegant trick called positional encoding. It's like adding a little bit of extra information, a special code, to each word's location on the map. This code tells the AI, hey, this word is in position 1, this one is in position 2, and so on. It's kind of like adding page numbers to a book to make sure you always read the story in the right order.
So let's put it all together. We've got our three steps: tokenization, embeddings, and positional encoding. When you combine these three ideas, what you get is the foundation for a true revolution in AI.
Before these transformer models, older AI had to read a sentence, one word at a time. It was really slow, and it would often forget the beginning of a long sentence by the time it got to the end. But now, by processing everything at once, transformers are lightning fast and can understand the context of huge documents with no problem.
Okay, so theory is great, but let's put your new knowledge to the test. Let's look at how this stuff actually applies in a real-world scenario you might see in your career. So, imagine this. A company's customer service chatbot is really struggling. It's super slow to respond, and worse, it gets totally confused when customers ask long, detailed questions. Now, based on everything we've just learned, what kind of AI model should they upgrade to?
If you guessed a transformer-based model, you are 100% right. Let's break down exactly why.
So why are they the perfect fix? Well, first, transformers process information in parallel, which makes them way faster. Second, they have this amazing ability called self-attention, which lets them connect all the important ideas in a long conversation. And, most importantly, they have a deep awareness of context, which means they don't get lost, even when questions get complicated.
So let's wrap this up with the key takeaways. Just remember these 3 things. 1. Tokenization breaks the text into small, usable pieces. 2. Embeddings gives those pieces meaning and context. And 3. Positional encoding tells the AI the order of those pieces. That's it. That is the fundamental process for how modern AI reads.
You know, understanding this isn't just a cool tech fact, it's like gaining a new superpower. It empowers you to build, to create, and to think more critically about the technology that is changing our world so fast. So the real question isn't just what you learned today, but now that you know the secret, what are you going to do with it? If you found this video helpful, please like the video and subscribe to Enhance Smart Skills for more videos like this.